Hi everyone, today's lesson is on similar triangles and the postulates that go with similar triangles, such as angle, side, etc. So let's get to it. So the first postulate that we're going to review is the AA postulate, which basically says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Basically, your angles, the third angle is going to be congruent to the third angle of the other triangle based on the fact that both of these angles are already congruent. If the angles are congruent, then the sides will be proportional, making the triangle similar. Just to recap, we did go over this in a previous video, but postulates and theorems for proving. A couple chapters ago, we completed a unit on congruent triangles. And within the unit on congruent triangles, we talked about the ways that you could prove that two triangles were congruent. We had the side, angle, side, angle, side, angle, angle, side, and hypotenuse leg. What's important here is that regardless if they were talking about sides or angles, both sides and angles had to be congruent in order for the two triangles to be considered congruent. But with similar triangles, in this little enye here that represents similar, you have side, angle, side, and angle postulates where the angles are congruent, but the sides are in proportion. So that's really important when you are trying to figure out postulates and what is congruent and what isn't. So remember that your sides are not going to be necessarily congruent if their triangles are similar. The sides will be in proportion. There will be a scale factor. The angles are congruent. Whereas if you're trying to prove two triangles congruent, the angles are congruent and the sides are congruent, both. So the questions here are basically what postulates would prove triangle FGH is similar to triangle JKH. Something that you do know is that this angle here is congruent to this angle by vertical angles being congruent. So you see that you have angle postulate. This angle is congruent to this angle down here. This angle is congruent to that angle. They are similar based on the angle postulate. For this one also angle postulate, because you do know that there's a couple of things here. If I were to take this triangle right here off and I were to say, move it aside, okay? So like, let me get rid of this one. If I were to take, okay, let me redo this. If I were to take this triangle here, all right, and I were to move it across like this, okay? This angle, so now you have the large angle or triangle like this, okay? And you've got the small triangle which starts at A. This angle is going to be congruent to itself, despite the fact that I moved it off the other triangle. So you have this angle congruent to itself. You also have this angle here, which is a corresponding angle here, right? You have that angle congruent to the big triangle. So this wouldn't be here because that would be in the small one right here. So you'd have in the large triangle, you've got this base, and then here you've got this angle. So those are corresponding angles. So that's again the angle postulate. What's wrong with this? Basically, this is not right. What's wrong with the solutions is that when you're doing this and you're trying to line up a proportion, you know that those angles are congruent. You know that you're going to make a proportion where you have the bases to base. So you have like X is to 8. However, to get the scale factor, you're going to go 6 is to 9. Side is to side, like that. But what's happened here is that the reason this is wrong is because they went and they said, well, 6 is to 8. So they went a side is to a base. And you're not ever going to do that. For this problem right here, you would say the scale factor would be 6 is to 9. You would reduce that by 3, and you get 2 is to 3. So that's my scale factor. And once I have my scale factor, I can find x by saying x is to 8, smallest to large, as smallest to large. So that's as 2 is to 3. I would cross multiply, get 3x is equal to 2 times 8, which is 16. So x would equal whatever 16 divided by 3 is. Okay, they're not asking, oh, they are asking us for the correct solution of x, which is 16 over 3. So for this one right here, we're just going to separate the two triangles. So I'm going to redraw this right here. And I have this triangle here. So I'm going to move this triangle here. And then I'm going to redraw the larger triangle. Okay. And what I want you to do is to try to separate these and then write your values on the side. So like this is 10. This value would be x because that's this length here. However, if you want the whole side here, you don't say 6, you say x plus 6 because that's going to encompass the entire side. And then your base is 14. So that when you're solving this, you're going to say, well, first of all, I would ask you, what's the scale factor? What's the scale factor? For this problem here, you can't go x is to x plus 6 and actually get a scale factor. You have to have a known side. So you'd say 10 is to 14. So 10 is to 14 is going to give me my scale factor. I'm going to divide by 2. I'm going to get 5 is to 7. So that's my scale factor. All right. So once I have my scale factor, what I can do is I can set up a proportion. And I can say 5 is to 7. So I went left is to right, as left is to right, as x is to x plus 6. So I'm going to cross multiply. And let me get rid of this stuff. I don't know what this is. Okay, hold on. We're going to cross multiply. And then when we cross multiply, we're going to get 7 times x is equal to 5 times x plus 6. Okay, so take a minute, try to work that out. And in working that out, I'm going to get 7x is equal to, I'm going to distribute 5x plus 30, all right? And then I'm going to subtract 5x from both sides. And I'm going to get 2x is equal to 30, so x is equal to 15. So if I want to find like questions that they might ask me might be, what's x? X is 15. Or what's the length of this side? And that side would be whatever 15 plus 6 is. Okay, so that'd be 21. So they might ask you, the different lengths or the sides. So for this problem here, again, it's a triangle. I could find y by going 4 is to 2 as y is to 3. That would be totally fine to do that. But personally, I always like separating my triangles. I really do. I feel like you just can see so much better if you separate everything. This would be 4. This would be x. See, there's your 4 and x for the small triangle. Then for the large triangle, this side is now 6. The base, also 6. This right side here is y plus 3. So my scale factor, to find my scale factor, I can't go x is to 6 because I don't have, it's an unknown. I can say 4 is to 6. See how I have the same value? So 4 is to 6. So my scale factor is going to be 2 is to 3. So in order to find, let's say, let's see, that side is y plus 3. I forgot to put this side in. There's y. So in order to find, let's say, y, I'm going to go 4 is to 6, which is 2 is to 3. So 2 is to 3 as y is to y plus 3. I'm going to cross multiply. And doing that, I get 3y is equal to 2 times y plus 3. I get 3y equals 2y plus 6. Subtract 2y. I get y is equal to 6. Okay, so there's y. To find x, where's x? X is on my base. I'm going to go x is to 6 as 4 is to 6. And 4 is 6 is 2/3. I'm going to cross multiply. 3x is equal to 2 times 6. So x is equal to 4. Okay, so I have x is 4 and x is 6. So this is a proportion that you're going to try to find the height of the redwood tree. So there's x. So in order to find the height of the redwood tree, we are going to set up a proportion. So again, I really appreciate it when I see two separate triangles. So that triangle is this one right here, all right? And so that's 12. That's 4.5. Okay, and this is a height, so it is right angle. And then I've got the large triangle that looks like this, okay? And this whole base here is already done for me. It's 430. And I don't know this. I'm going to try to find that. So we're going to make a proportion, and I'm going to say 4.5 is to x. So 4.5 is to x as 12 is to 430. So I'm going to cross multiply. I don't know. Let's see here. 12x is equal to 4.5 times 430. I'm going to divide both sides by 12. And I actually get x equals, for this value, I get 161.25. So we'll say 0.3. And so that's what x equals for this problem right here. Definitely check with a calculator, okay? This proportion is a little bit different. It's very similar, of course. I'm still trying to find the height of the redwood tree. But for this problem, again, I do want to split this up. So I've got this triangle here, okay? So this looks like it's 4.5 again, but this is 2. Yeah. And so the large triangle, though, okay, for the large one, I'm still trying to find the height, but I have a different value here, and I need to use a little bit of common sense because they're looking for this as my base, okay? And if this is 2, this is 95, my base is going to be 97. And so setting this up, we're going to say 4.5 is to x as 2 is to 97. I'm going to cross multiply. 2 times x equals 97 times 4.5. I'm going to divide by 2. So x equals 97 times 4.5 divided by 2. And for this one, I believe I got approximately 218.25. Okay. Find the scale factor. Okay, so be careful. This side is proportional to this side here. Okay, so it's kind of like twisted. Okay, it's like you know how you wring out a towel? It's like that. So like this is proportional with this, and 5 is proportional with x. Now, the problem with finding a scale factor with 5 and x is you can't. I can, though, find the scale factor of 3 to 4.5. So 3 is to 4.5. Now, a couple of things with this, you don't leave a scale factor like that. So you're going to say, well, that's going to be 3 to 4.5 is like 4 1/2. Again, you don't leave it like that. So what you're going to do is, well, that's 9. That's 8 plus 1 is 9. So 3 is to 9 halves. Okay, so that's 3 divided by 9 halves. So 3 divided by 9 halves is, just a second. And that's not going to move. Anyway, so I'll just do it right here. So 3 divided by, like this. See how I'm going from here over to here. We're ignoring the x and the y right now. So 3 divided by 9 halves is going to be 3 times 2 over 9. Multiplying across, I'm going to cancel and reduce first. So I end up getting my scale factor is equal to 2 over 3. So 2 over 3. So that's my scale factor. So once I have my scale factor, now I can just pretty quickly find x and y. So remember, we went small is to larger. So for me, I'm going to go 5 is to x as 3 is to 4.5, which we reduce to 2 over 3. We're going to cross multiply. 2x equals 5 times 3, which is 15. I'm going to divide by 2. I get x equals 15 over 2. Okay. To find y, let's see. Base is to base. So we're going to go y is to 9 as 3 is to 4.5, which reduced again to 2/3. And we're going to cross multiply. 3y is equal to 9 times 2, which is 18, So y is equal to 6. And we better to put your answers in solution sets, more proper. The two polygons shown here are similar. You're supposed to write a similarity statement. Fill in all the missing angles. So that's 60. That means that's 60. There's 65. What else? We have 100. 160, 65. I think that's 120, 35. 135, something like that. And so we're going to go, similarity statement is going to be PSRQ is similar to, if I started with P, I'm going to start with L. So it's going to be LONM. Actually, MNO. LMNO. I should have done this way, meaning I should have said PQRS is similar. I started up here and went that way. PQRS is similar to LMNO. Okay. Anyway, you could, either one is fine. Either both correct. Same thing with this. Polygons are similar, but I do notice that they are flipped. See the right triangles here? I'm not sure if you can see that. There's a right triangle here, and there's one here. So you actually would need to flip this around. Personally, I always I always redraw my shapes all the time. So for me, I would be redrawing this shape. Okay. Okay, maybe. Let's see here, moving this over here. So I want to redraw that. So in redrawing that, it's going to look just like this. Okay, so we're going to go, and what I'm going to do to redraw this, I know you can't do this, but I'm going to take this little shape, I'm going to move it over here, and I'm just going to make it bigger. And maybe that's cheating a little bit. I don't know. But so anyway, there's my new right angle here that was here. This is now 140. Here's my right angle, which of course that makes that 90. Here's 100, etc. So just know that that's how you're going to do that. You're going to fill in the angles by just subtracting from, let's see, what kind of shape is this? 1, 2, 3, 4, 5. So it's a pentagon. So you would go 180 times n minus 2. This is going to give me the sum of the angles interior. Okay. So basically you would go 180 times 5 minus 2, because 5 sides, 5 minus 2 is 3. 180 times 3 is going to give us 540 degrees. So the sum of the angles in both of these triangles is 540. So 90 and 90, what's that, 180? You've got 100, you've got 140. So add 8, 12, 1, 2, 3, 4. So you got 420, subtract 420 here, you get 0, 2, 1. So the last angle is 120 degrees. Okay. That's funny. For this one right here, they said that ABC, so ABC is similar to ADE. Okay, so like I said again, I really feel that it's so important to just redraw these triangles. And it is, I prefer that any day. Here's A, here's B, here's C, here's A, here's D, and here's E. And what you need to remember is that angle A is the same angle. And also, if these lines are parallel, that makes these angles here or these angles here corresponding. So that means that this also is congruent to that. And so and then of course, B is going to be congruent to D. Now we just have to fill in the sides, because now that my angles, of course, triangles are similar. They already said that. So I can make a proportion here. AB is 12, BD, so BD is here. So that's 3. So we know AB is 12 and BD is 3. So the whole length is 15. Then you know CE is Y, okay? And BC is X. DE is 8. So there's 8. That's X. What do I need to do? Find X and Y. So, I just have to find X and Y. Oh, where's Y? Y's here. Do I know AC? I know AC. AC is 10. So this is 10. And AE is 10 plus y. That's what that is. Okay, so my scale factor is going to be equal to 12 over 15. If I reduce by 3, I'm going to get 4 over 5. So that's my scale factor. Okay, so once I have my scale factor, which is 4 over 5, now I can make, I could solve all these values. I can go x is to 8 as 4 is to 5. And cross multiply, I get 5x is equal to 8 times 4, which is 32. So x equals 32 divided by 5. To find y, I'm going to go 10 is to 10 plus y. So I'm going small is to large as small is to large. 12 is to 15. So that's going to be 4 is to 5. I'm going to cross multiply. I get 5 times 10, which is 50, is equal to 4 times 10 plus y. So 50 equals 40 plus 4y. Subtract 40, I get 10, is equal to 4y. And divide by 4, I get 10 divided by 4. Divide that by 2, I get what, 5 halves? So y is equal to 5 over 2. Finally, a proof. Okay, so we have a proof. You need to be careful because you are given that angle 1 is congruent to angle 2, all right? But if you notice the triangles, they're sideways. They're not quite right. So what they're saying is that ABC, here's ABC. So watch. Here you got A, go right, B, C, all right? So we're going to take that triangle. That's my ABC. I'm going to label it. So here's A, go right, B, here's C. And it's similar to EBD. Okay, so I'm not even going to look at the triangle or I'm not going to draw it on here and move it over because it's turned sideways. What you need to remember is that if you start high at A and you go down right to B, okay, then your similar triangle is going to also start high, whatever it is, and go down right. So this is going to be E, down right is B, and then last value over is D. So that's how you do it. You have to set them up exactly the same. If you don't set them up, your proportion will be incorrect, okay? A couple of things you should notice. Okay, A is 2, so here's 2. That's congruent to E angle, which is 1, okay? So those are congruent. You also know that B is the same angle in both triangles, so that's congruent to itself, all right? So given, number 1, you're going to say angle 1 is congruent to angle 2. That's just given, all right? But you also know that they didn't tell you this, but you should know that angle B is congruent to angle B, and that's because of the reflexive property of congruence. And I think what we're trying to prove is that they're similar and that they're also proportional. So now we know angle, 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 angle. Okay, so we can say the two triangles are similar because we have angle, angle. So we can say that triangle ABC is similar to triangle EBD because of the angle, angle similarity postulate. Okay, well, now that the triangles are similar, then the sides are proportional. All right, so you do need to kind of look at this and go, okay, what are they trying to say? AB is to what? BC? Let's see. AB is to BC as AB is to BC as EB is to BD. And that what that is corresponding parts of similar triangles are proportional. Okay, and so now I can actually cross multiply and go AB times BD is equal to BC times EB. And all I'm doing is cross multiplying. Different books call this different things, but technically you're multiplying, you're cross multiplying. There's another, multiplying. There's another definition or reason for this, and we did this in class. It's called the POP, meanings and the extremes. Basically, you're cross-multiplying, okay? For this one right here, again, notice the triangles, how they're set up. They're given that these are similar. You need to draw them exactly like this. See how it says R down S, T? I need that triangle. So I'm actually going to move that over here. That's RST. So we have R, we have S, we have T. But RQP, if you notice, this is sideways. That's different. I want this has to be the same as this. That has to be written exactly the same. So I'm going to draw my triangle in, okay? So if this goes RST, this is going to go R left Q and then P. And a couple of things. Number one, R is congruent to itself, right? Check. You also know that RT is 12. That's 12. TQ is 3, and RT is 12. So that means RQ, this whole length, is 15. RP is 8 more than RS. We don't know what RS is, but we do know that RP is 8 more than that, RP. So that's 8 more than that, okay? So that's going to be X, RP is X plus 8, okay? So RS we don't know, but we know that RP is X plus 8. So we're going to multiply these out. I don't have a scale factor. We have X is to 12. Now keep in mind, I can go left side is to left side. So I could go X is to 15. Or I can go X is to 12, S15 is to X plus 8. That's your choice. Either one's going to give you the same answer. So I chose to do X is to 12 as 15 is to X plus 8. Okay? You're going to cross multiply. You're going to go X times X plus 8 is equal to 12 times 15. And so this makes X squared plus 8X is equal to 12 times 15. Do it on the side. Do not use a calculator. That's 10. Add 1. 5 times 1 is 6. Excuse me. 5 times 1 is 5. Add 1. 6. 2. 1. We have 0, 8, 1. 180. All right. Subtract. We have x squared plus 8x minus 180 is equal to 0 because it is quadratic. You know, as soon as you hit a quadratic, you need to set it equal to 0. Okay, we know x times x is going to give me x squared. One's going to be plus, one's going to be minus. To get 180, I'm probably going to go 18 times 10 because that's going to add up to 8 if I subtract. So it is positive, so I'm going to get a positive 18 and a minus 10. I'm going to split this up. I go x minus 10 equals 0, so x equals 10. I go x plus 18 equals 0, so x equals negative 18. So if I go back and I look at my answers, this is important. Please look at this 18, negative 18. Can x possibly be a negative length? Can you have a negative, can you measure and go, that's negative 18 feet? No, you cannot have a negative length. This is the side of a triangle. You know, in algebra, you would say, well, can I have, it's quadratic. You got to have two answers. Your teacher or whoever was teaching you would say, you have to have two answers because it's quadratic. But in geometry, you do have two answers because it is quadratic, but not both of them are going to be correct. They're not going to both work because what you have here is a negative length, but you have to show that you did get that answer. So you're going to say the correct way to write this would be 10 is correct, but 18 is what we call extraneous because that means that it's an answer, it's a solution, but it didn't work when I plugged it back in. So it's an answer, but not a solution. So again, I use the word extraneous, okay, which basically means it's an answer, but it doesn't work when you plug it back into the equation. Okay. Oh, look at, like, this one's already done for us. Let's see here. Scale factor, 24 is to 20. Oh, that's done here. We're going to reduce that to 6 is to 5. let's say in order to find x, where's x? X is here. So you're going to go 30 is to x as 24 is to 20. And we already reduced that. So you'd say 6 is to 5. We would cross multiply. We'd go 6x is equal to 30 times 5. Divide by 6. So x equals 30 times 5 divided by 6. And what is that? 6 goes into 35 times, 5 times 5, so x is equal to 25. Okay. All right, so we know that ABC is similar to A prime, B prime, C prime. So their scale factor is 7 to 9. Now, perimeters also have the same scale factor, by the way. And so therefore, if the perimeter is of ABC, which is the first one, which is my 7, okay, is 42, we're trying to find the perimeter of ABC. So we're just going to call it, I don't know, x, cross multiply, 7 times x equals 9 times 42. I'm going to divide both sides by 7. I'm going to get x is equal to 42 divides into 7 divides into 42 6 times. 9 times 6 is 54. So my perimeter, so you'd write, this means therefore, the perimeter of triangle A prime, B prime, C prime is 54. Okay, cool. Quadrilateral PQRS is similar. Again, this means similar to quadrilateral TUVW. One side of PQRS has a length of 12. The corresponding side has a length of 15. So that's our scale factor. 12 is to 15. Reduce that. Because this is PQRS. This is TUVW. We have scale factor. Let's see here. What are we going to divide by 3? So we're going to get 4 is to 5. So there's my scale factor. Now the corresponding side has length of, oh, we already did that. The perimeter of be careful. Here's 4/5. The perimeter of TUVW, remember TUVW is on the bottom. So that's going to go down here at 35. What's the perimeter of the top? So we'll call that, I don't know. We're going to multiply across. We're going to go 5 times x is equal to 4 times 35. We're going to get x is equal to whatever 4 times 35 divided by 5 is. And so we know that 5 divides into 35 7 times. 4 times 7, we get 28. So 28 is the perimeter of PQRS. And so like you would write that. You would write on the side, you'd go, okay, I'll do it over here. Therefore, 28 is the perimeter of PQRS. The perimeters of two similar polygons are 20 and 28. So we're going to just line those up, 20 and 28. We're going to get our scale factor. I'm going to divide by 4. I'm going to get 5/7 scale factor, SF. One side of the smaller polygon, which is this is smaller than this, has a length of 4. So we've got 5 is to 7 as 4 is to, what's this corresponding? That's just x. So we're going to go 5x equals 5 times x equals 7 times 4. Divide by 5, x equals 28 divided by 5, and that's my answer. These two triangles are similar. What's the scale factor? Well, you can't go 10 is to y because you don't know what y is. You can't go x is to 21 because you don't know what x is. So if you really need the scale factor, remember, you need number to number. So that's going to be 20 is to 24 divided by 4. I'm going to get 5 is to 6 scale factor. Once I have my scale factor, I can find x and y. And remember, if you go small is to large, then you have to set up your proportion like that. Small is to large. So like I'm going to go x is to 21 as 5 is to 6. I'm going to cross multiply. 6x equals 21 times 5. X equals 21 times 5 divided by 6. Ooh, 6 is actually 2 times 3. I'm going to divide 3 into 21 7 times. So it looks like my answer is going to be 7 times 5, which is 35 divided by 2. And let's finish that. X equals 7 times 5 divided by the 2. And we can leave our answer like that in a solution set. Okay. So that's all I have for you regarding similarity and their postulates, and I hope that helped. Thanks for watching.